This is AP Calculus AB Self-Check 4.3. In number 1, we're asked to find the equation for the line tangent. I should probably underline that in pen. Whenever you have an equation for the line tangent, you always do point slope form, which is y minus box is equal to box times x minus box. Why my palm is hitting that weird, I guess. All right, so what is our x value? Well, this tells us our x value is -1, so therefore we will plug in a -1 in for our x value. Our y value is usually what we're going to do as well, but I don't see a y value, which means we need to plug a -1 in for both of these x's. When we do that, I can write out what's going to happen. I'll have f of -1 now is equal to 4 times that -1 to the power of 3, or cubed, minus 5 times -1, then plus 3. So remember, whenever we have a negative to an odd power, that will always stay negative. So we can say that this is going to be equal to -4 plus 5 plus 3, and that's going to be equal to 4. Therefore, my y value is 4. We can plug that in up here, 4. All right, the next and one of the last things we'll have to do is to find what our slope is. To find our slope, we need to take the derivative. We need to find f prime, so let's do that now. F, and I have a feeling that we're going to need to rewrite our form over here. These are not point slope form, those are in slope intercept form, so I'll give that room, and then I'll do my derivative down here. F prime of x. Okay, when I take the derivative, this 3 is going to come down in front. 3 times 4 is 12. And x goes down to the power of 2 for our powerhouse. Then I'm going to say -5, as the derivative of -5x is just -5. And then from there, yet again, we're going to plug in -1 into our x over here. So this is going to be f prime of -1, and that's going to be equal to 12 times that same -1 to the power of 2, or squared, minus 5. And this is going to be, let's see, well, -1 to the power of 2. Any even power is going to make this always a positive. Therefore, it's going to be a positive 12 minus 5, and 12 minus 5 is 7. Therefore, the slope here is 7. So there's the answer. And I'm noticing that answer, as I said before, is not listed over here, as these are all in slope-intercept form. We have point-slope form, so we need to do some distribution and simplification. First I see is the double negative makes this a positive, and I'm at the same time going to distribute the 7 into both of those. So let's see, this is going to, let's do a new color over here. We're going to say this is going to turn into y minus 4 is equal to, okay, 7 times x is 7x, and 7 times a positive 1 is a positive 7. Last step, we're going to move our -4 to the other side by adding 4 to both sides. When we add 4 to both sides, we get y is equal to 7x plus 11, which is our final answer. 7x plus 11 is option C. In number 2, we're seeing that we have an x-coordinate, a y-coordinate, and a derivative. We're trying to do an approximation, which means we need to use that line tangent, the equation of the line tangent, to do that. Whenever you see line tangent, that's always going to be the same thing. It's going to be y minus box is equal to box times x minus box, that point slope form. All right, it tells us what my x-coordinate is, what my y-coordinate is. I can fill those in right now. My x-coordinate is 2, my y-coordinate is 1. And it even helps me with the slope. The slope is 4. I can plug that in over here as well. Slope is 4. I have my equation ready to go, and I'm now going to approximate what 1.9 is, plugging that in for x. Let's do that now. I'm going to say y minus 1 is equal to 4 times that x value minus 2. The x value, again, is that 1.9. 1.9. So you should be able to start solving these in your head, but in case you don't know how to do that, let's go ahead and go nice and slow. This is going to be 4 times -0.1. My stylus is not working quite right. And then when I multiply those, I'm going to get -0.4. And then I'm going to add 1 to both sides. When I add 1 to both sides, I'm going to get 0.6, a positive 0.6 for option B. Moving on to number 3. We're asked to find y prime. Again, this is the same thing as saying y prime. Therefore, I need to find a y prime. There needs to be a derivative. Just be careful, because this is going to be product rule. That's 1d2 plus 2d1. Let's go ahead and take the derivative. First, I see my y squared. The 2 is going to come down in front for my powerhouse function. It's going to be 2y, and instead of to the power of 2, this is now to the power of 1. Don't forget your dinner. This is our derivative of the outer. The derivative of the inner is going to be a y prime. Now I have to be careful. There's a few different ways to do the product rule here. So the first way that I'm going to be doing it is I'm going to consider all of this negative 2x to be my first function. I'll say that's my first function, and this y is going to be my second function. If I do that, I'll still get the right answer. And I can also do it another way. I can also say I'm only going to take the derivative of xy, where x is 1, not the negative 2. And then after I find the answer, I will distribute negative 2 into the product rule. I like doing it this way because I don't want to worry about distribution later. I'll do it now. All right, so here's product rule. 1 is negative 2x. D2 is the derivative of y, or y prime, plus 2. 2 is my y. And then D1, the derivative of negative 2x is negative 2. So times a negative 2 here. And now I'm done with product rule. I can rewrite the equal to sign, and I can take the derivative of 21, which is 0. All right, I have everything ready to go, and I know that you can start simplifying for y prime, but instead I'm going to plug in as soon as I can. My x-coordinate is y, my y-coordinate is negative 3, my x-coordinate is 2, I don't know what I'm saying. So I'm going to say 2 times my negative 3. I still have a y prime that I'll be solving for, minus 2 times my x, which is positive 2. Still times y prime, and that's going to be adding my y coordinate, which is negative 3. I want to do this like this, negative 3 times my negative 2. That's all still set equal to 0. All right, simplifying just a wee bit, we have negative 6 y prime minus 4 y prime, and this is going to be plus 6 is equal to 0. I'm going to do two things at the same time. First, I'm going to subtract 6 on both sides to bring that 6 to the right-hand side, so I'll have a negative 6 on the right-hand side. And I'm also going to combine like terms. These are both y primes, so I have a total of negative 10 of those y primes. And then from there, I'll divide both sides by negative 10 to get y prime is equal to a positive 6 over a positive 10, which reduces, because we can divide both the numerator and denominator by 2, to get 3/5. Our final answer should be 3/5, and that means our correct answer here is option E. I want to circle the whole thing. There, that feels nice. All right, moving on to number 4. We are asked to find y prime. Again, this is the same thing as saying y prime, so I'm going to take the derivative. The derivative of x squared is 2x. You might be asking, isn't there an x prime? Yes, x prime with respect to x is just 1, so I don't write it. Again, we have an xy, so this is invoking product rule. 1 is x, d2 is y prime, plus 2, which is y. d1, the derivative of x is 1, so I don't write the 1, I just don't write anything. Plus, now I'm going to take the derivative of y to the power of 3. The 3 is going to come down in front, and I have y to the power of 2, correctly applying the differentiation with product. I was going to say product rule. Man, my mind is not working right now. With powerhouse, there we go. And then don't forget your dinner. The derivative of y is y prime. And this is still set equal to 0. Unfortunately, we have nothing to plug in, so we have to do some rearrangement. The first thing that I'm seeing is there are two terms that don't belong. This 2x and this y are going to go to the other side by subtracting that on both sides. So I have x y prime plus 3y squared y prime on the left, and on the right-hand side, I have a negative 2x and a negative y on the right. From there, I will combine, actually, I'll factor out my y prime term. So I like showing my work for the y prime factoring out because a lot of students struggle with it. When I factor out a y prime, that means my y prime has been factored out, and what's left over is whatever that quotient is. The y primes will cancel out, leaving behind an x, and these y primes cancel out, leaving behind a 3y squared, I'll copy down that plus sign, and this is still set equal to the right-hand side, which has not been changed, 2x minus y. And then from there, I have y prime by itself. If I divide by all of this x plus 3y squared, when I divide both sides by x plus 3y squared, I'm left with y prime by itself, which is equal to a negative 2x minus y all over an x plus 3y squared. Just as a reminder, and that my answer might be over here. I'm going to check it in a sec, but as a reminder, whenever we have a fraction, we can always multiply the top and bottom by -1. I can multiply the top and bottom by -1 because this is just multiplying by 1 and not changing its value. If I do that, that is the same thing as saying 2x plus y in the numerator and a negative x minus 3y squared in the denominator. So both of these answers are correct. We'll see which one is listed. I'm seeing, oh, okay, they actually pulled this negative out in front. and didn't distribute it through. That's why there's a negative out in front like this. Let's see, 2x and y, 2x and y, x and 3y squared, x and 3y squared. The correct answer in this one is actually A, which is interesting because they factored the negative out of the numerator. All these other answers are close, but not quite right. In number 5, we're given a function, and we're trying to approximate f of 1.5 at... Okay, so I'm seeing the words line tangent. Whenever we have line tangent, you know what we're about to do. We do the point slope form. Y minus box is equal to box times x minus that box. All right, what x coordinate? Well, x is pi over 2, so I will put in a pi over 2 for my first box. I need to find my y coordinate, which means I need to plug pi over 2 into my function. So let's do that now. I'll say, and I'll do this scratch work on the side. I'll say f of pi over 2. I'm plugging in pi over 2, so I'll change the color here to let you know that I'm plugging things in. Pi over 2. When I plug in pi over 2, I'm going to rewrite everything else. I'm going to say 2 cosine of that pi over 2. And this is still plus 1. All right, what's that right-hand side? Well, I know where pi over 2 is, just as a way to remind you if you don't have your trig memorized. Pi over 2 lives right here. Pi over 2 lives up. Cosine is asking how far left and right have you moved. I have not moved right. I have not moved left. Therefore, I've moved 0. This whole thing evaluates to 0. And 2 times 0 is 0. And 0 plus 1 is 1, so this is equal to 1. So I'm going to say that my y-coordinate is 1. And then finally, I need to find the slope. To find the slope, I'm going to take the derivative of f to get f prime. Let's do that now. F prime of x. Let's see. The derivative of cosine, c stands for change, so I'm going to change its sign to a negative. And then cosine and sine always flip-flop, so if it was cosine, now it's sine of x. And when I take the derivative of plus 1, it turns into a 0, so I don't write my plus 0. All right, now that I have the derivative, again, I will be plugging in pi over 2 into my x, Let's go ahead and write that down now. I'm going to say f prime of that pi over 2, and that is equal to negative 2 sine of that pi over 2. Again, we still have the same spot, pi over 2, from up here. Now, sine is asking for the y-coordinate. How much up and down did you move? Well, I moved all the way up on the edge of the unit circle meaning the radius is 1. I moved up a total distance of 1. This entire thing evaluates to 1. Let me go ahead and write that down. That whole thing evaluates to a positive 1, and a positive 1 times a negative 2 is a negative 2. So I can come down here and say this is equal to a negative 2. Therefore, my slope in here is a negative 2. All right, I have my equation ready to go, and now I'll do my approximation for f of 1.5, meaning this 1.5 is plugged in for x. Let's write that down now. I will rewrite y minus 1 is equal to negative 2 times the quantity of 1.5. Now, I should change color since I'm plugging in 1.5 minus the original pi over 2. So a lot of students will struggle and say, I don't know how to do 1.5 minus pi over 2. It's okay. Notice that the answer contains pi anyway. So the first thing that I see here is that I want to distribute the negative 2. So that means that the left-hand side is not changing. The right-hand side is going to have a negative 3. And if I distribute the negative 2 again, the 2's should cancel out. The negatives will also cancel out because a negative times a negative is a positive. So I'm just left over with pi. So it's going to be a positive pi over here. I don't know why I switched to green. I'll go back to red. Plus pi. And the last step is to add 1 to both sides to get y by itself. So if I add 1, this turns into a negative 2 plus pi. Is there a negative 2 plus pi or pi minus 2? Oh, there's a pi minus 2. That's going to be option C. Awesome. That does conclude the self-check 4.3 for AP Calculus AB. There's the back side. There's the front side. Thank you for watching.